Okay, what we're going to do here is take a look at some of the formula that we find in Chapter 3. And we're going to do it in two parts. So we'll do the left-hand side of the page first. And you might wonder, well, what are all these formulas for? Well, by knowing the formulas, you'll see that it's going to really help you in, first of all, understanding the questions they're going to ask you, and then later doing some examples. So as we see Formula 1, where we have ax plus by equals c, this we call is the standard form of a linear equation in two variables. Now, if we take the letter y, that's right here, and in any tip, let me give you an example of this. This will be 3x plus 2y equals 6. So as you go through Chapter 3, in the beginning, you'll see equations like this. Well, this is a specific example, but this is the standard form here, where a is 3, b is 2, and c is 6. So, standard form. Notice that in standard form, we don't have any fractions. These are all integers, the a, b, and c. Now, if I take this y, and I solve this equation for y, watch what happens. We get 2y. Now I'm going to transpose this 3x by subtracting 3x and then subtracting 3x from the other side. Now, when we transpose, we just take a term from one side of the equation and bring it over to the other side of the equal sign and just change its sign. Again, it's like subtracting 3x from both sides. And then we get plus 6. Now, to solve for y, and we did some like this in Chapter 2, we're going to divide every term by the numerical coefficient of the variable, which is y here. And the numerical coefficient is 2. So we're dividing that by 2, and we divide this by 2. And this gives us then y equals a negative 3/2 x plus 3. So we have converted an equation that was in standard form to what we now call slope-intercept form by solving for the letter y. Now, a little later on in the chapter, you're going to solve an equation and get something like this, y equals mx plus b, and you're going to have to put it back into standard form. We'll go over that a little later, but right now, we're just solving for y, and we got slope-intercept. Now, an interesting thing happens when we do this, by the way, because we see in Formula 2 the letter m. Well, the letter m stands for slope, which in Formula 3, that's that formula. This is the slope formula, and we'll be using that in the middle of Chapter 3. But right now, what we have as the numerical coefficient of x, that I'll put right over here, that's our slope. And then we have this letter b. b, by the way, wherever it shows up, is the y-intercept. So that's why this equation number 2 is called slope-intercept. Okay, we'll get back to some of these as we go on too. All right, now equation 3 is the slope formula, where if we have two ordered pairs x sub 1, y sub 1, and x sub 2, y sub 2. These would be any two ordered pairs. We put them in this formula very carefully and grind it out, and that is the slope of these 2 points if they're connected by a line. That would be the slope of that line. Another thing about slope is that it's a ratio, basically, of y units to x units. Y is rise, and x unit is run. So this is the vertical, this is the horizontal. I'll be going over that shortly as well. All right, going on to Formula 4, and I believe this is in section 3.4. We have another formula that's called point-slope form of the linear equation. Now you'll notice here we have the slope, and here we have one ordered pair. Now if we have one ordered pair and we have the slope and we substitute into that, we can then generate an equation that's in slope-intercept form. In fact, let me do one of those. So let's say we have the slope is 3, and an ordered pair, let's say, is -2, 1. So with that, where we have the m, we're going to put a 3. Where we have the -2, that's our x term, that's going to go right there, -2, and put that in parentheses, and then this is our 1. It goes right there. Now we rewrite the equation. Y minus 1 equals 3 times x. Now it's minus a -2 makes this a +2. Now we get rid of parentheses. Y minus 1 equals 3x plus 6. I'm going to transpose this -1 by adding 1. So my equation now, y equals 3x plus 7. And that equation now is in slope-intercept form, like equation 2. And we use the point-slope form for it. All right, I'm going to erase what I have here. Remember, you can always rewind the tape, but we're going to go on a little bit further down here. Now, let's look at equation 5. Equation 5 is a special equation that by definition defines a horizontal line. And we use the letter B, and later we're going to use the letter A here, because that sometimes is used for the ordered pair XY, AB. So this B is going to be some value of Y, and this A is going to be some value of X. And let's see how it works. So if we have an equation in the form y equals b, or let's say y equals 4, this is what we have here. 1, 2, 3, and then there's 4. It's a horizontal line going through the y-intercept. That is, it's going to cross the y-axis at 4, horizontal line. And a little bit more information that I have on this page is that the slope of a horizontal line is 0. In example 6, a special form is x equals a. Remember, a is the x coordinate member and b is the y. So there's a relationship there. Now, so whatever a is, so if we had an equation like this, x equals -2, then this point right here is -2. This would be -1 there, -2. So vertical line going through -2. Okay? Now I also put here what the slope of that line is. Any vertical line on a graph, the slope is undefined. So you see, so far we've done a number of things using some of the formula, putting them all together on one page of notes to help you master some of the skills in Chapter 3. All right, looking at equation 7 and 8, I should say. Let's see if I can raise it up a little bit here. Now, formula 7, it's not so much a formula as it is some facts, that if the slopes of an equation are the same, that is, m sub 1 equals m sub 2, but the y-intercepts are different, the lines are parallel. Same slopes, different y-intercepts, the lines are parallel. In number 8, again, this is informational. We're using the slope of one line, multiplying it by the slope of another, and if the product of these slopes is a -1, then these lines are perpendicular. So there is, for instance, if this first slope was 1/2 and the other slope was a -2, that would be a -2 over 1. Everything would cancel out and you'd end up with a -1. These lines are perpendicular. We say if the product of one slope is the negative reciprocal of the other, which then gives you the answer of -1, the lines are perpendicular. Now, before we leave this page, let me just do one other thing here. I can get my pen over there. We go. All right, one of the major items I'm stressing throughout all of this is making a T-chart. So a T-chart is where you would put various values of x and then solve it, put that value of x in the equation, and then you get a value of y. And these are ordered pairs along a particular line that represents an equation on a graph. So often we would pick like a -1, a 0, and let's say a 1. Some points that are around 0, we put that in, get corresponding values of y, plot these 3 points, that's our line. Now a special one, and I have this on the other side, but I wanted to show it to you now. A special T-chart is this one, where you put a 0 here under the x, skip a spot, and then under this y you put a 0. Now this special T-chart is going to give you values where, by putting it in the equation you have, whatever you have for y, that's going to be b, that is the y-intercept. And when you put a 0 for the y, you're going to get the a here, and this is your x-intercept. And what do we mean by that? Well, let me see if I can get a little graph going here. There's a graph, and there's a line. So this line crosses, I'm going to try to change colors here, the y-axis at this point, that is the y-intercept. That's what this one is. And this crosses the x-axis at this point, and that's what this one is. So this, when you have 0, b, that's the y-intercept. And when you have a, 0, that's the x-intercept. And these are very good methods of solving what points you need to plot a graph. Okay, this is a quick summary. I don't want to spend a lot of time, but normally in a regular class going over all these in detail might take, 2 class periods. But here we've done it in this short time. Later I'll come back and we'll do part 2, which will be the other side of this.